Hello everybody, it's Mr. Pagachnik again, and today we are doing the guided notes for 5.2, and we will be covering gravity, gravitation, and orbits. So, what is mass? Well, first off, mass is how much matter an object contains, and different objects contain different amounts of matter. So the elephant and the mouse contain far different amounts of matter. The unit for mass is the gram. And often, a gram is pretty small, so we talk in kilograms, which just means 1,000 grams. And one way we can measure them is on a balance pictured down in the bottom right. We can also use an electronic balance as well, so we don't have to worry about moving the masses around. So wait a minute, what is weight? If mass is mass, what is weight? Well, different objects contain different amounts of matter, but matter feels heavier or lighter depending upon the force of gravity. So, on the Earth, we have a certain amount of gravity, and our weight is the downward pull on an object due to its gravity. So when you step onto a scale, it's going to give you your weight. And we typically use the Newton, or what's more common would be a pound. We're used to what a pound is. Now, if you went to the moon, things would be a little bit different. So mass and weight compare. Mass and weight are both measuring a property of the object. But mass is going to be a different measurement than what weight would be. Weight depends upon mass and the gravitational pull on that mass. The mass doesn't change no matter where you go in the universe. The weight would change based on the gravitational pull. So an example would be taking that heavy mass and putting it on Earth. It would have a certain weight. If we went out into space, it would be weightless, but it would still have the same amount of mass. And if we brought the mass to the moon, it would still be the same mass, but the weight would be about 1/6 of the amount on Earth. So an example would be if that thing weighed 120 pounds on the Earth, it would only weigh 20 pounds on the moon, and it would be weightless in space. So, talking about mass and weight on the moon. The mass of the moon is about 1/6 the mass of the Earth, like mentioned in the previous slide, which is why it looks like the astronaut is bouncing, because his muscles are used to having to push a certain amount to get him to walk. Well, when he keeps pushing that same amount, it pops him up into the air because he's pushing way harder than he needs to. So it looks like he's jumping around all the time. So here another mathematical example would be if that astronaut weighed 180 pounds when he left Earth, he would only weigh 30 pounds on the moon. And while he was flying in space, he would have weighed 0. He would have been weightless. But that doesn't mean he changed his mass. His mass never changed. At least not much. If the sun is the center of our solar system, how do Earth and other planets orbit it? Well, as you can see in the diagram, that planet is spinning around the sun, and the moon is spinning around the planet. So an orbit is the path of an object in space as it moves around another object due to Newton's laws, gravity, and inertia. The orbit of one object around another object is called a revolution. Here we see the Earth revolving around the sun, and the moon revolving around the Earth. So one object revolves around another object. And why? Well, because of gravity. This is an interesting picture because this is what they think gravity is kind of like. Like an object kind of puts a dent in the fabric of space. And the bigger or more massive the object, the bigger kind of dent it makes. So what is gravity in terms of astronomy? Well, as you can see in the image, a bigger object tends to have more gravity. It's more massive. And the smaller object is less massive and has less gravity. And it's the attraction between the two objects that we call gravity. So it is a natural force of attraction between the two objects. It's a force of attraction between any two objects, but we don't really feel it very much, from one person to another. But we can feel the effects of gravity on the Earth. If you trip and fall, you're going to feel it. Now, the amount of gravitational force is determined by mass and the distance between two objects. So the amount of gravitational force between the Earth and the Sun would be different than what's between the Earth and the Moon because they're different distances and they're different masses. So the greater the mass, the greater the gravitational force. So the Sun has a lot more gravitational force than the Earth, and the Earth has a lot more than the Moon, and the Moon has a lot more than a person. The greater the distance, the less the gravitational force. So if the Earth was further away from the Sun, there would be less gravitational force acting on us. If we were closer, there would be more gravitational force. There will actually be a simulation where you will get to play around with that a little bit. How does gravity explain how Earth and other planets orbit the Sun? Well, if you look at that picture, there's something going around another object, so that would be revolving. And it has a velocity, and it is trying to go in a straight path, but the gravity of the object keeps trying to pull it back in. So the Sun's gravitational force acts like a string. So imagine that object is spinning around that axis. The gravitational force would be a string holding it. So it just keeps going in a kind of a circular path, mostly circular. We call it an ellipse, but it's mostly circular. Gravity supplies the centripetal force that the planets need to orbit the Sun. So that's the string, essentially. So, how do Newton's laws explain how Earth and other planets orbit the Sun? Well, the force the Earth exerts on the Sun is equal to the force the Sun exerts on Earth. However, the Sun is much more massive. So this force will have a larger effect on the Earth than the Earth would have on the Sun. The Sun remains almost completely stationary because it's so massive. It does move a little bit because all the planets are moving around them and they all kind of tug on the Sun a little. So it does move a teeny bit while the other planets orbit it. And there you can see the direction of gravitational pull from the Earth towards the Sun. Okay, and inertia. So what is inertia? Well, inertia is the tendency of an object to keep moving in a straight line. So if you watch that car, it keeps going, it hits the wall, but the person doesn't hit the wall. The person gets ejected from the car because they had inertia, which is why we have to wear seatbelts. So with planets, they want to keep moving in a straight line unless a force acts on them. Well, the gravity from the Sun is that force that acts on them. So how does the relationship between gravity and inertia explain how the Earth and other planets orbit the Sun? So again, inertia wants to keep planets moving in a straight line. Gravity wants to pull the planets right into the Sun. The balance between them is what keeps the planets orbiting. So if gravity was a little stronger, we would get pulled into the Sun. And if our speed sped up, we would probably fly away. We need to have that balance, and we are in a path right now where we are pretty well in balance. Gravity pulling us in, and our own tendency to want to keep moving pulling us out. Okay, here's one more little diagram. It shows the distance between the Earth and the Sun, and the gravitational pull pulling us in. And the Earth's motion without the Sun's gravitational pull would be in a straight line. It would just want to fly away, but the Sun keeps us there. Now we're a little bit closer to the Sun on January 3rd. We're a little further on July 4th. That's when we're a little further away. So we're not a perfect circle, but we're really, really close. Now what would happen if gravity suddenly disappeared? Well, first off, it won't. But if it did, that wouldn't be good. The Earth and other planets would continue to move in a straight line according to Newton's first law. We would just fly off into space. Now, unless the mass or the distance between the two objects changes, the orbit would remain the same. So, orbits have a predictable and regular motion. So as long as nothing changes, we should keep going where we're going. But if gravity disappeared, we'd fly off. So, do the planets really orbit the Sun? We say that the planets orbit the Sun, but technically they each orbit the mutual center of mass. Well, because the Sun is so massive, the Sun is basically right in the middle, and that's the object we are going around. But it's not quite perfectly in the middle. That's why we have that elliptical orbit. Because the sun is so much more massive than the planets, the mutual center of mass is very close to, but not exactly at the center of the sun. So it's actually a little bit off center. So the center of gravity, or center of mass in our solar system, is almost in the middle of the sun. And the Earth's orbit is almost a perfect circle. It only varies by about 3%. So those numbers were given in the previous slide. And that is the end of this presentation on gravity and gravitation. So some things to think about. What is gravity and what does it do?